Next is putting the complex representation of bandpass signal and the system all together. Before and all we studied about the separate that is the bandpass signal complex representation and bandpass system complex representation. Here together we all done. The figure shows that the input output description of the bandpass signal. The input bandpass signal is S of t and output we can call it as an X of t with the multiplication, that is a bandpass LTI system H of t. LTI is nothing but a linear time invariant system, and there are two procedures we can define either in the frequency domain as well as in the time domain. Let us consider the frequency domain. Let X of t be the output of a signal of a bandpass system produced in the response of an incoming signal S of t only, where X of t has its own low pass complex envelope called as a X tilde of t. And X of t is, we can write it as in real terms of X tilde of t into e to the power of j 2 pi fct, and the output signal we can call it as X of t is equals to S of t convolution with H of t, where we can know that the convolution is can be done by H of t into S of t and S of t into H of t, both are same only. So here we can write it as a convolution step. We can write this minus infinity to plus infinity integral of H of tau into S of t minus tau into d tau. We know that and consider the pre-envelopes of H of t is equals to real terms of H plus of t and S of t is equals to real terms of S plus of t. This is a pre-envelope of H of t and S of t signal. Therefore, we can write it in the above equation as X of t is equals to, where H of tau can be replaced as a H plus of tau, that is real terms of real changes real t changes to tau, H plus of tau into, where S of t can be written as real terms of S plus of t is there. For the pre-envelope, for a convolution it changes to t minus tau into d tau. Therefore, the property of pre-envelope we know X of t is equals to 1 by 2 into real terms of integral varies from minus infinity to plus infinity S plus of tau into S plus of conjugate tau into d tau, and X of t is equals to, that is this we know by the property of a pre-envelope. This we applying to the above equation, we get the 1 by 2 into real terms of integral varies from minus infinity to plus infinity here H plus of tau into S plus of t minus tau into d tau, where here if we multiply this signal with an e to the power of j 2 pi by fct, we will get the 1 by 2 into integral of minus infinity to plus infinity h tilde of tau into e to the power of j 2 pi by fct into s tilde of t minus tau. Here is of S plus t minus tau is there, so we will get S tilde of t minus tau into e to the power of j 2 pi fc plus t, wherever t is there it changes to t minus tau with respect to d tau, and we will get X of t is equals to 1 by 2 real terms here. If we take e to the power of j 2 pi fct as a common here, because e to the power of j 2 pi fct into fc, this is a tau, because with respect to tau we are doing e to the power of j 2 pi fc tau into e to the power of j 2 pi fc, this is a minus tau, this and this get cancels. Therefore, the remaining terms are h of tau integral of if we take e to the power of j 2 pi fct tau only, integral of minus infinity to plus infinity h tilde of tau into s tilde of t minus tau into d tau, where we can write it as an x tilde of t is equals to 1 by 2 integral of minus infinity to plus infinity. Here we can cut as this t. Minus infinity to plus infinity x tilde of t into its similar looks like a convolution signal only, x tilde of t into s tilde of t minus tau into d tau, and here